Alright, so let's move into the problem number 27 now. And this problem is about quadratic prime. Let's read out the problem. The problem talks about certain quadratic equation in this form: n square plus an plus b. In this case, n square plus n plus 41, where a is equal to 1 and b is equal to 41. So according to this formula, it says if you use n is equal to 0 to 39, for all these 40 cases, you will find a prime number. For example, n is equal to 0, this becomes 41. If n is equal to 1, this will become 43. So all of these numbers should be prime numbers. Okay, all 40 consecutive numbers are prime numbers. However, if you just increment it to n is equal to 40, this is no longer becoming a prime number. However, there is another formula, another incredible formula found, where it says n square minus 79, that means a is equal to minus 79 plus b is equal to 16001. In this case, we can prove that for n is equal to 0 to 79, that means total 80 prime, consecutive prime. However, if you make n is equal to 80, this will no longer be a prime. Okay, and here you have noticed that a and b can be both positive and negative value, however they will be integer. So in this case, here the modular of a is 1000. That means a can be positive and negative. Now the question is asking for all these cases, a less than 1000, that means a can changes from minus 1000 to plus 1000. Similarly, b can change to, here a is not including, that means minus 999 to plus 999, and b will be minus 1000 to plus 1000. For all this combination, what is the maximum consecutive prime we can get? That means what is the value of n, okay, for which max value of n from 0 to which position of n can give us consecutive primes. That's what it's asking. Please note one thing. In this case, we have b is equal to 1601, which is greater than 1000. So we may not get this number in our search. But okay, let's see how we can solve this problem. Okay, let's jump into our coding. Problem number 27. I'll just keep some more cell here. Okay, so let's have a look. First of all, we'll have to create a function which finds out if the number is prime or not. So I've already created such a function in my previous examples, many examples. So I'll not write down this code right here. Instead I'll just copy the function for convenience, and I'll just explain what we have done. So is prime number, here we are checking if number is divided by 2. Number is equal to 2, then 2 is a prime number, we are returning 2. But if number is divided by 2, that means other than 2, but it is divided by 2, that means it is not prime because it is divisible, therefore we return false. Now for I is equal to 3 to square root of that number plus 1, and I'm incrementing 2, that means we'll search from 3, 5, 7, etc. No need to search for 6, etc. because those are not prime, we know. So in this case, if we find at least one of them is divided, that means the number is not prime, otherwise number is prime. So we can test it. For example, is prime 11, that's true. If we do a 12, that's false. If we do 13, that's true. It's like that. Okay, now what we'll do is we'll just try to find out our quadratic prime count. Okay, so let's create another function. The function is let's get quadratic, I'll just say quad prime count. Okay, let's say this function will take a and b as parameter, and then it will create our formula, quadratic equation, and find out how many such n, 0 to how many positions it's giving us the prime continuously. So n is equal to 0. That's our starting n. Then let's say y will be our formula. y is equal to n square plus n plus an plus b. So I'll initialize y as b, because you know for n is equal to 0, the quadratic equation becomes like that. Other two terms will vanish. Now let's say count is equal to 0. This is going to be our count. I'll also keep track of the list of prime numbers in our example. So I'll just keep track of it for our tracking part. Now I'll create a while loop. I'll say is prime. I'll check if is prime y. That's the output of our function. Then if it is prime, then I'll just increment 1 n by 1, and then prime list, I'll just append the prime list as our y value. Then let's calculate the y. y is equal to n square plus a multiplied by n plus b. This is the actual quadratic equation. Then count, because remember we are just trying to count the total number of prime. Well, it's done. I'll just increment the count, and at the end of it I'm just going to return count. Okay, now let's just test with the equation. So I'll say get quad prime count. Here A, B, C. First example, A was 1 and B was 41. I think there's something wrong. While is prime y, A is equal to count plus is equal to, okay, that's a mistake. Okay, so you have to increment the count. Okay, so yeah, for 1 and 41 we are getting 40. Now the next number was minus 79 and 1601. So now we are getting 80. So that number is matching. Okay, if you really want to have a look at let's say if you really want to have a look at our prime list, let's try to find out. In this case, just increment. Let's see how many prime number. You see, we are starting with 1601, and interestingly at the end we are also getting 1601. Okay, if we also try with say 1 and 41, you see we are still getting 41 and it's ending with 1601. Well, this could be a coincidence, but we have noticed that in both the cases we are getting exactly same list of prime numbers. Have a look at this. For the other cases, if I just create a set, that means if I just want to increment, these numbers are repeating actually, minus 79 and 1601. You see here again we are getting exactly same number. But the first cases we got only 40 prime, and second cases we got 80 primes. These primes A and B are chosen such a way that these primes are repeating, duplicating. Anyway, so the question is asking for us is this count only. I'll just change our function back. Okay, so next what we'll do is we'll have to do our search. So we'll have to create a loop, start our loop. So I'll create a max value as 0. I'll say max A equal to 0, max B. I want to keep track of both A, B and the maximum count. Then I'll create a loop for A in range. So it says A not including 1000, range 999. It should be minus 999, minus 999 to plus 999. For B in range 1000, minus 1000, minus 1000 to plus 1000. Now we'll have to count. Count is get quadratic, get quad prime count. Then I give A and B, and then we are checking the maximum count greater than max. Then our max is equal to count. Our max of A is equal to A max. Well, this is not really max of A. Maximum value of AB is just the value of AB for which we got the maximum count. Just to be clear, max B is equal to B. Okay, now let's run. Okay, another thing we'll have to see probably. Some cases okay, let's see what happens. Okay, you see there are some exceptions because some cases it will create some complex number for the negative number, because negative square root, it might create complex number. That's why I'll just use a simple try. I'll just use a simple exception handling, except pass. Okay, now let's have a look. What is the max value? Max is 71. That means we'll get 71 consecutive numbers, and max A is 0. It doesn't look right. Max B is 0. Okay. This is a max B is this, and max A. Okay, let's do it here itself. Max A minus 61. So minus 61 and 971. These are the value. Okay, just for curiosity, I want to check what are the prime number we are getting. Okay, instead of count, let's return the prime count. And if I just want to see get quad prime count minus 61 971, you see probably we are getting exactly the same list of prime numbers. Yeah, we are still getting from 41 to till 1601. We are probably getting the same set of repeatable prime values. But anyway, the question is asking for this, the product of this. Okay, so this is what the question is asking for. This minus 59 231. So let's try this out. Yeah, our answer is correct. I think that's it for the current edition. Thanks for watching. If you like my video, please share and subscribe. And thanks again for watching.